Our hopefully for tonight, pages 396 and 397 only. 396, 397 only. All right, our our objective for today, I can write, solve, and graph rational functions. Once again, I can write, solve, and graph rational functions. Last week, we did solving and graphing. What do you guys notice different? We're going to write today. The second part of the lesson is giving you a graph and you writing the function. Now, we did this before with cubic functions. I don't know if you guys remember that you have the cubic function and you needed to write the general rule and you substituted values and stuff like that. We're going to do that again, but now with rationals. However, we're still going to do some graphing because I'm going to give you a different type of rational and we need to rewrite it. So, we don't need a Fourier model because we already know what rational functions are. Last week, I gave you these 3 steps. Look up. We needed to identify the asymptotes, build an input-output table, and graph. Today, to graph, look the steps for graphing. Last week, today. Last week, today. Last week, today. Telling you the only thing that changed. Step 1, copy step 1, and then from there you're going to write, then follow the graphing process. Copy that. I'll give you some time. 30 seconds, go. Today we're going to what? Write equations. So I need a different process for writing equations. Here we go. To write equations, given a graph, here are the steps. Step number 1, write the general transformation rule for rational functions. Step number 2, identify the vertical and horizontal asymptotes and substitute those into the rule. Step 3, identify a given point and substitute values into the rule. Step 4, solve for the remaining variable. And step 5, rewrite the function and graph. Copy that. I'll give you a little bit of time, but then they're going to come up with steps later on, so don't freak out if I take them off earlier. So, all right. Once again, these 5 steps, I'm going to have them, as we get to that part of the lesson, come up later on. But I want to get us started really quick. So, quick recap. Last week, I brought back the general rule. Is that correct? But then I said our new rule for rationals would be this. And we said that it had the same kind of transformations within the rule. Is that correct? However, what did we say that H and K were? 2 different things for the rationals, right? Before, for the general rule, it was just a transformation moving it from right to left or up and down. But now they were also our asymptotes. What were asymptotes? Invisible lines that we get close to, but we never touch. And we worked on what? Vertical and horizontal. This week, we're going to cover oblique, slant, or diagonal. However, here it goes again. The H is our what? Vertical. Our K is our horizontal. Okay. Last week, I gave you guys stuff that looked like this, and it looked straightforward, kind of like this. A 1 on the numerator, and then whatever we have down here. Let's see. Yep. And then the constant right there. Today, we're going to cover stuff that looks like this. Last week, today. Last week, today. Last week, today. Now, that's why for step 1, we have to use what? Long division to rewrite this to make it look like what we did last week. So copy that. Example 1, it says, rewrite the function and graph, identify the domain and range. All right, before I get started with this, quick recap in regards to some of the properties that we covered at the beginning of the school year in Algebra 1. Here goes 1. Let's see, 2 plus 3. Can I write it as 3 plus 2? Yes, what allows us to do that? Commutative property of addition. Okay. Another. If we have a fraction such as 1/2, as soon as I do this, it becomes a negative. Is that correct? What if I do this? Still a negative. What if I do this? Still a negative. But for what we're doing with rationals, anywhere where that negative is at, we have to change it to look like that. The negative has to go where? In front. Does everybody understand that this, no matter where I place it, is the same as this? Are we there so far? Okay. And last but not least, when we covered graphing, when we first started with rationals, I said our first graph or rationals looks like this. And I said this is a parent function. That means that our vertical asymptote is x equals 0, and our horizontal asymptote is y equals 0. Y equals 0 is right there. X equals 0 is right there. What does that mean, Mr. Q? That we can get close to, but not touch. From there, we build an input-output table, and our graph will look like this. And I said, that will never change. That will always be there in that form. Now, the only thing that's going to change is that these two are going to move either up, down, left, or right, depending on the transformation of the rational. For example, if I gave you this, if we were to set it equal to 0, what would be our vertical asymptote? -3, which means if it's -3, it's going to move our function, the entire function, 3 steps to the left. And this one's going to move it how many steps up? 5. So this whole thing, these two are going to move 3 to the left and 5 up, so it's going to be somewhere over here. Is everybody following? Because the asymptotes are what? -3, 1, 2, 3, there it is. And +5, 1, 2, 3, 4, 5, there it is. That's why it's going to move. The other thing I said, the other thing is that this is only for positives. What happens when it's a negative? It's going to reflect about the x-axis or the horizontal. That means this one's going to reflect over here, and this one's going to reflect over here. Yes? All right. So, back to this one. Writing utensils down, look up to the screen. So I'm going to do step 1, which is long division, to rewrite this. So let me zoom in. Here it goes. Do you guys see a fraction here? It's a division, is that correct? This divided by that. So watch. 3x minus 4 divided by x minus 1. What number times x gives me 3x? 3. So 3 times x is 3x. 3 times -1 is -3. I'm going to subtract. And what does that do to this? It's a negative. And what does that do to this? Positive. So this cancels. We're left with -1. Are we there so far? All right. So if I need to rewrite this, what is my whole number right now? 3 plus the remainder. What was my remainder? -1 over x minus 1. Is everybody following so far from our long division? Okay. Now, according to the commutative property, I can move this one to this side and this one to the back so it can start looking kind of like the functions we did last week. So therefore, check this out. I'll leave it right there. I'm going to take this whole term and move it to the front and this one to the back. So I end up with what? -1 over x minus 1. What sign is this? +3. Is that starting to look now what we did last week? Yeah, except for this is not a +1. This is a what? Negative. Do we have a fraction here? Can we place this negative anywhere? It has to go where? In the front. That means if I factor out the negative, I end up with -1 over x minus 1 plus 3, and all that equals to g of x. Copy that. Let me zoom out. Copy that, gives you some time. All right, I think we got it, yeah? Once again, long division, write your whole number, and then your remainder as a fraction. Rewrite this. This goes on the first term, this at the end, so it can be our constant. You can't have the negative either on top or on the bottom. It needs to go where? In the front of the fraction. There it is. And it makes the entire fraction a negative. Okay. Now that we have that, we can graph this. So your neighbor, the vertical asymptote. X equals what? 1 is correct. It's right there. Our horizontal asymptote. Tell your neighbor what y is equal to. 3. There it is. All right, so let's plot those. 1 is right there. So my vertical asymptote goes through 1 of x. Now earlier somebody asked, Mr. Q, why do we do a dotted or a dashed line? Because it's telling us that it's invisible and we can't touch it, like MC Hammer. Huh? Y equals 3 is right here. Once again, vertical asymptote going through there. Now, for the purpose of today's lesson, we're not going to make a table, but we know how to graph this. Is that correct? All right. So, look up, please. If this was a regular rational function, look up, it would be here. Is that correct? However, this is not a regular one. What is it? It's a negative one. Tell your neighbor where I'm going to graph that. Not here, but opposite or flip it. So it's going to go right here. And instead of here, it's going to go up here. All right, before we move on, tell your neighbor why I know that it goes here and not up here and not up here, down here. Talk it over to your neighbor, please. All right. Let's see, I think Steven's got it. Steven, so why do we graph it here and here, not here and here? Because it's negative. That is correct. This negative inverts the graph from here to down here, and from down here to up here. How are we doing? Good? Okay. Copy this one. Example 1 super cube. We got g of x equals 3x plus 8 over x plus 2. I'll give you a head start for that one. See if you can write your function using long division. Copy that and go. All right, check your work up to right there with the long division. And if you got it to right there, at least by yourself. Okay. However, we need to rewrite that rational. Is that correct? So the fraction goes on front. So we got 2 over x plus 2. And then at the end, plus 3. And all that equal to g of x. However, what do you guys notice? Can we have a 2 on the numerator? No, it needs to be a what? A 1. So what are my factors of 2? 2 times 1. So if I move this one to the front and left just the 1 there, my new function would be g of x equals 2 times, what's left? 1 over x plus 2 plus 3. Does everyone understand why we can do this? Because if we had an invisible 1 underneath. That times that is that. This times this is this. So we can rewrite it like that. Yes? All right. Let's graph. What's our vertical asymptote? Tell your neighbor, please. X equals -2. That is correct. Our horizontal asymptote is y equals 3. All right. Zoom out. So 3 of y, it's right there. And x is -2. Going to -2 of x, which is here. All right. Now, does this have a negative in the front? No, so that means it's right here. This is a regular function. Now, some of you are asking, Mr. Cube, but doesn't the 2 do something to it? Yeah, it's going to make it like a little bit smaller or whatever the case, but it's always there. Is that correct? All right, how are we doing? Good? Let's do another one. Example 1 cubed. G of x equals 4x minus 7 over -2x plus 4. Let's do this one together. We got 4x minus 7 divided by -2x plus 4. All right. What number times -2x gives me positive 4x? -2. So we end up with positive 4x minus 8. Subtract. That makes this a negative. This becomes a positive. So we end up with positive 1. Okay? So what's my whole number? My whole number is, bless you, -2 plus my remainder. What's my remainder? 1 over -2x plus 4. Commutative property, can we move it around? Yeah, we end up with what? 1 over -2x plus 4, and then minus 2. And all that equal to g of x. However, do you see a negative on that fraction? Yeah, this one. But how can we get rid of it? Oh, I see. GCF here? Yeah. G of x equals 1 over -2 times x minus 2 minus 2. And now that we have it as a factor, now we can get this negative to the front. Not -2, just a negative. So this would be what? G of x equals -1 over 2 times x minus 2 minus 2. Right? So we can move the negative anywhere we want, but what did we say we're going to move it to? Right here to the middle? Yes? All right, so vertical asymptote. X equals what, Victor? 2. Horizontal asymptote. Pass someone, Victor. Y equals what? -2. That is correct. Let's graph that. -2 of y is down here. Positive 2 of x is right there. All right. So, does my function go right here? Let me show you the function. Does it go there? Tell your neighbor, why not? Because it's a negative. So I erase those because they're going to go reflected down here and up there. This one reflects down here, and this one reflects up here. Why? Because it's a negative. The what? For this? Okay. 2 equal to 0 doesn't work. X minus 2 equal to 0. Plus 2 plus 2. X equals 2. Yeah. How we doing? Can we come figure out with these? Yeah, we got these, yeah? Piece of cake? Crack it up 3 notches, yeah? Copy this one. Example 2. It reads, write the equation of the function given the graph. Use the form g of x equals a times 1 over x minus h plus k. Copy these instructions, and you don't have to copy the graph. We're going to do the work from the graph, okay? Now, purposefully, I left the steps down here because some of you didn't finish copying them, but here they are. I'm going to go through the process just to make sure we got it, okay? Once again, it reads, example 2, write the equation of the function given the graph. Use the form g of x equals a times 1 over x minus h plus k. Now, refresher. Now that we're in rationals, what does the h also represent? Very good. Our vertical asymptotes. And what does our k also represent? Our horizontal asymptote. Okay. So that means if we want to write an equation using this form, we need what? Our vertical asymptote, our horizontal asymptote. Don't we need also an x value? Don't we need also this value? This would be a y value, yes? So it would be the only variable that we would need to solve for. Okay, so check this out. Step 1 says, write the general form or transformation rule. We have it right here. Step 2, identify the vertical and horizontal asymptote. So, look at the graph. Tell your neighbor the vertical asymptote. What's the vertical asymptote? X equals what? Negative 2. Negative 2. Next, we want our horizontal asymptote. That would be y equals to what? 1. There it is. Okay. It says, identify the vertical and horizontal asymptotes and substitute into the rule. So I'm going to substitute in here. Ready? So I'm going to rewrite that. G of x equals a, parentheses, 1 over x minus, but instead of h, what am I substituting in there? Let me put parentheses for those of you that don't see it. Instead of h, the vertical asymptote is what? Negative 2. And instead of k, what am I substituting in there? 1. All right, let me rewrite that one more time just to make sure you're following along. G of x equals a, parentheses, 1 over x plus 2 plus 1. So this looks like what we've been doing. Is that correct? But don't we need a number here because we have another variable, which is a. How do we figure this one out? Well, check this out. Do they give us 2 points? They give us at least a point. Yeah, I'm going to use this one. This point right here, given, because it says step number 3, identify a given point and substitute. So what is the x value of the given point? I'm going to use -1. What is the y value? -3. But instead of y, I'm going to label that what? G of x. Let me substitute that into the equation. So g of x is what? -3. And what is x? -1. So we have a parentheses 1 over -1 plus 2 plus 1. Before I move on, tell your neighbor where I got this value of x and this value for g of x. Yeah, I used the point given. They gave me 2 points, this one and this one. I used this one. There it is. Let me simplify. Let's see. We get -3 equals a times 1 over 1 plus 1. What is 1 over 1? What is 1 times a? So this is a plus 1. All right, and all we have to do is solve for a. Is that correct? Yes. -1 minus 1, -4 equals a. So, do we have an equation already here? A function? Yes, but what is the only value that we were missing? A. So I write g of x equals, instead of a, I'm going to substitute what? -4 parentheses 1 over x plus 2 plus 1. Here goes recap one more time. We start off with our rule. What do we need in order to get started? We need to write it, number 1. Number 2, we need to identify the vertical and the horizontal asymptote by looking at the graph. Here's the vertical, here's the horizontal. Substitute those values, rewrite. This will be our equation. However, we need to identify what a is. How do we find a? Well, we need to solve for a by substituting an x and a y value, or an x and a g of x value. Could I have used this point? Yeah, x, g of x. I could have used that also, but I decided to use this one. I substituted values, simplified, and solved for a. Now that I have a, I just substitute it in here, and there it is. Now, let's see if it's true. What is my asymptote here? The vertical, -2. Is it going through -2? Yes. What is my horizontal? 1. Is it a negative? That means it's inverted? Yes. It's down here and up here. There. Oh, let's go. All right, show me if I can be over these. Okay, let's do another one. Oh, yes, we love these. Copy this one. Example 2Q. So step 1, you need to write the form that they give you. And by the way, this is given in the problem. They're going to tell you use this form. So that's the form that we use. Because there's another problem that they're going to say instead of a, you need to solve for what? B, which they're going to give you 1 over b in front of the denominator. So now that we have this, we need our vertical asymptote, x equal, and our horizontal asymptote, y equal. Tell your neighbor those two, please, according to the graph. Jasmine, our vertical. Close. And our horizontal, alley, 4. Hands if you got that. That is correct. So we substitute those in here. Instead of H, what goes there? 3. And instead of K, what goes there? 4. So my new function is g of x equals a, parentheses, 1 over x minus 3 plus 4. Okay. But now we have a to solve. So that means we need to use one point. Which point do you want to use? 4, 6, or 2, 2? 2, 2. So I'm going to use for x 2 and for g of x 2. So my new equation is 2 equals a, parentheses, 1 over 2 minus 3 plus 4. What is 2 minus 3? Negative 1. So what is 1 divided by negative 1? Negative 1 times a. So this is, I'm going to show you this stuff because some of you are looking at me like, what? 1 over negative 1 plus 4. This becomes negative 1. So negative 1 times a is negative a plus 4. And now we just solve for the remaining variable, yes? So we got minus 4 minus 4. Negative 2 equals negative a. How do we get rid of that negative? Divide by negative 1. So therefore 2 equals a. So we take this function, since we already substituted the asymptotes, and we get g of x equals, instead of a, what do we write? 2 parentheses 1 over x minus 3 plus 4. Can we come to you out with these? Yeah. Now, the home plate is going to give you one of these. Look up. What do you guys notice on this one? Do we have an A? No, now we have a what? B. But the process is the same. Start with the asymptotes, substitute a point, and then you solve for the remaining variable. Okay? Once again, your home plate, guys, is on pages 396 and 397 only. Enjoy. Make it a family math night. See you guys tomorrow. Bye.